So students, in the last module we have discussed about the analysis and issues and potentials, and we have understood that how we will use the data in order to come to the analysis, identification of issues and potentials and constraints for development. So now let us understand that for planning, because planning is for the future, we plan for the future, we need to forecast. And why do we need to forecast? Because we need to know the future requirements. And what do we need to forecast? We need to forecast the population, the land requirements, the requirements for infrastructure, that is the physical infrastructure, water, power, and then we need to also forecast about the facilities which need to be provided, education, healthcare, civic facilities. You know what is social infrastructure all about, which we had discussed earlier. So all these facilities also we need to know the future requirements so that we can plan. Now we also estimate, apart from doing this physical, apart from the projections, or apart from understanding the projecting the future requirements, we also need to know the land requirements. That means how much land would be required for the future city. Estimations are also done for the future traffic volume, for the emissions, that is the airborne waste, the effluents, the waterborne wastes and the solid wastes, so that one would plan for the management. The first step of forecasting is to forecast the population, rather the future population for which we want to plan. So there are various methods of forecasting or projecting in order to find out the future population figures. We have the arithmetical increase method, which is the linear method, then the geometrical progression method, we have the incremental increase method, we have the logistic curve method, the exponential growth method, and the graphical method. So there are a number of methods in order to forecast. As you can see from this table, in the arithmetical increase method, the rate of growth is lower as compared to the geometric progression method. Vis-a-vis, if we see the exponential growth method, we see that the exponential growth is considered. So the lowest growth rate, if you see, is for arithmetical increase method is low. In geometric progression method, the rate of growth increases, and in the exponential growth, the rate of growth further increases. And these are the considerations for doing the population projections. There are these equations are given. You can have a look at these equations. And another way of population projection is through plotting population onto a graph, and these methods are the logistic curve method and the graphical method. So as you can see from these calculations, how the population estimates vary through the usage of these various methods. Through the arithmetic progression, the population estimates are much lower, and then for the geometric it's a little bit higher, and then for exponential is substantially high. Now how do we choose which figure or what would be the future population from these estimates? So one needs to calculate the error. You can see the steps of calculating error given here. The estimates where the error is the least is considered as the future population for the city. So based on the population projections or the future population estimated future population, one needs, as I said earlier, one needs to assess the future requirements for housing. So how do we do it? And what do we need to do in this? So first thing is that we need to find out future housing requirement. That means for X amount of population, how much would be the requirements for housing, and that is calculated based on addressing the existing backlog, existing shortages in housing, and in addition to that fulfilling the additional requirements. You can see from this slide how this is calculated, what sort of assumptions we require, and what are the various steps. We need to also estimate how much water would be required for future. Water for various sectors is calculated and the total is estimated, which would again address the or overcome the existing shortage. In addition, the additional requirements need to be fulfilled. So you can see from this table how water supply, what are the various sectors and how the calculations are done. Similarly, for solid waste generation, one needs to know that for the future population, how much would be the solid waste which would be generated in future, so that we can have a, as I mentioned earlier, that so that we can manage. So therefore, you can see from this table how one calculates the area, how one calculates the and with the waste generation, we also need to know the land area required for if there are landfill sites. For the water supply, for the future water, to meet the future water demand, one, we calculate the requirement. Secondly, we require land in order to have water supply, water treatment plants, and water tanks, so water storage areas, so all that. So therefore it has a manifestation on the land area, so land is required for that. So land is thus estimated for in order to meet the future water demands, apart from a quantum requirement. As one of the very important infrastructure aspect, power supply is also, we need to know about the power supply which would be required in future in order to meet our various needs and demands of the future population. And you can see in this table how it is calculated. Now, in terms of a requirement in kilowatt hours, one calculates it, and then this also requires land, because transformers would require land, then the power plants would require land. So this is also a manifestation on land. To assessment of, similar to the assessment of the future requirements for physical infrastructure, we also have to estimate the future requirements of social infrastructure, that is how many schools would be required, so in terms of educational facilities, or how many colleges, universities, etc., or for that matter in terms of healthcare, how many hospitals, primary health centers, etc., and also civic amenities, and other facilities which we have discussed as part of social infrastructure. So we need to as I mentioned earlier, that the future requirement of social infrastructure would be, one is to meet the existing shortages or backlog or gaps. In addition, the additional requirement or for the future population needs to be added, existing gaps. So that would give us the total figure of the future total requirements of infrastructure facilities. One needs to also find out the future requirements of new roads, terminals, parking areas for planning for the future. Based on the existing analysis of the traffic volume, of traffic generation rates, and one tries to forecast the requirement for new network within the city. One tries to find out the requirement for new terminals, both for passenger as well as goods terminals, and also areas for parking. So all these have manifestation on land in terms of roads, railways, mass rapid transit systems, which can be either road based or rail based, as I had mentioned earlier. Then areas for terminals, areas for parking, all these would add on to the land area requirement for the future city. Here you can, from these tables, you can see how, from these slides, you can see how the traffic, from the traffic forecasts and from the traffic generation rates, the projections are done for the terminals and for the other aspects which I was referring to. So dear students, we had started off with the population projections, and then we went on to forecast the other requirements for various infrastructure and for housing. And now we come to the most important thing, is that how much land do we require for the future city? How do we estimate that? So there are, one method is using a town density, which is basically for various typology of cities, the various scale of cities, densities of the cities have a certain range. So based on the norms and guidelines, one can use figure or the density. One can use the density in order to calculate a gross land requirement for a total land requirement for the future city. But if you want to know sector wise how much land is required, then we need to work out for housing how much land we require for the city, the land required for various infrastructure facilities, like I was referring to, water supply plants, waste treatment plants, landfill sites, recycling areas, power plants, transform areas for transformers, then schools, or rather educational facilities, healthcare, civic amenities, then for new network areas, terminals, parking areas, and also for open spaces, planned parks, playgrounds. So for, and lastly, about land required for the economic activities, that is land required for industrial activities, land required for commercial activities, and also land required for maybe new tourism hubs. So all these are various sectors which require land, and these need to be considered for assessing the or estimating the future land requirement for the city in future. Now, what is the time period for how long do we estimate? For how many years do we estimate? Traditionally, master plans have projections in master plans have been for 20 years in cities worldwide. Maybe from 15 years to 20 years were the time period on which projections are done. But today, considering the fast pace of growth, maybe the time period can be phased out, and one can have short phases of 5 yearly or 10 yearly phases in order to calculate, in order to forecast the future requirements, so that we do not outgrow our calculations.